So let's continue. On to the next problem here. Miss Morrison is getting married, and soon she would like to hire a professional who will come to her house and do her hair and makeup for her bride. She's narrowed down to two possible choices. There is this woman from the Glen Grove Saloon, and then alternatively you have Beauty by Anita. So notice Beauty by Anita doesn't charge any initial fee where Oak Grove does. Oak Grove's cost is going to be Y equals $50 plus $10 per hour. X is the number of hours. But Beauty by Anita is just going to be Y equals 20X. That's going to be it. The job now is going to be to graph these things. The same thing, graph below, and see how many hours they'll pay to see them out. So let's graph Oak Grove first. It's going to start at 50, and the slope is 10. So let's see what color is that. I made that graph right. So start at 50. We're going to go up 10 over 1. 10 over 1. Notice the vertical scale here counts by tens. 10, 20, 30, and so on. So that's what this line looks like. So that's Y equals 50 plus 10X. The other graph, this one here, has a y-intercept of 0, but goes up by 20 every time. So it's going to start here and go up 20 over 1, 20 over 1, and so forth. And what you'll notice is now, if these two graphs meet up, here's y equals 20x, you meet up right here at this point, which is 5 hours and $100. So the point 5 comma 100 is the solution. That means that if you needed 5 hours worth of work, it wouldn't matter who you hired, it would be the same. If it takes 4 hours to complete the bios party, which saloon should you choose? Well, if you're only going to work for 4 hours, and that's all you need 4 hours worth of work, let's go to x equals 4 on the graph, and let's go up. So if you go up to the graph here, you can see it would cost $80 for Anita's company, but it would cost, let's use a different color now, let's use yellow. So we go up here and across, it would cost $90 to use Lake, or what is it, Glen, or Oak Grove, forgive me. So you should use Anita's because it's cheaper. If you show the points on the graph, that's good. All right, let's go to the next one. Freddie started with 20 baseball cards in his collection, then he bought an average of 2 cards per year. So let's make an equation just for that. So he starts with 20 and gets 2 a year. So y equals 20 plus 2x. Okay? And then there's this other person, Lewis, right? He starts with 5, and in his collection he grows by 5 per year. So y equals 5 plus 5x. Okay. So you could try and graph this in the calculator and see where they cross. It might be a neat thing to show you. You could do that. Let's try that. Let's go to the calculator. What I'm going to do is I'm going to go to y equals, and if anything's there, I'm going to hit clear. And I'm going to type in the equations. So if we remember, first equation was 20 plus 2x, and the second equation is 5 plus 5x. So here we go. So we're going to type 20 plus 2x. And here, I'm going to type 5 plus 5x. Okay. My recommendation is press Zoom 6 to get started. Zoom Standard, it's called. And let's see what the graphs look like. So what you can see is here, if you look at it, you can see the blue lines going off the top, and so is the red line. So they cross up here somewhere. I need the graph to go higher. So this is Y max. We want to increase that. So to increase Y max, you press a button called Window. Go down and find Y max. I'm going to change this number to, I don't know, I'm going to try 50. And we'll see what happens. I'm going to press the graph key. Ooh, that worked. I got lucky. So I can see they cross right here. If you want, you can kind of tell that's happening at 1, 2, 3, 4, 5. Looks like they cross at 5. I can't really tell what this Y value is. So you can do this. You can do second, calculate, go to number 5, intersect, and then just move the right arrow until you're really close to the point of intersection. That's all you got to do. Over here, I think that's pretty good. Just hit enter, 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 and you get the answer, 5, 30. So that's where these graphs intersect. So you'd want to graph them as best you can on here and show 5, 30 as intersection. So I think what I'd probably do is count by, I guess we'll do it this way. So 2, 4, 6, 8, that's 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. And then going across, I think I can just count by 1, 2, 3, 4, 5, 6, and so on. First graph starts at, if you look at the actual equation, it starts at 20 and goes up by 2 each time. So 20 up 2. Remember, this is 22 here. So this line looks like this. Perfect diagonal. There it is. It's y equals 20 plus 2x. The other line starts at 5 and goes up 5 each time. X goes up by 1. So 5 is down here. And then go up to 10. Right? And then it go up to 15. And then go up to 20. And then we go up to 25. And then go up to 30. 35. You can see now the lines intersect. Same thing we got on my graph. 5. Anything else to ask? Explain what this means. So, in the context, what that means is, remember, this is the number of years that have been collected. So, in 3 years, both people will have 30 cards. Okay, that takes care of that. Let's look at a few more questions. Some multiple choice. Which graph represents x is greater than 3? If you want x to be greater than 3, x equals 3 is a vertical line. So this can't be the answer, and this can't be the answer. So you're looking at choice 3 and 4, in both of these cases. Notice how we shaded to the right in both cases. That's because if you went to the right of 3, x would be bigger than 3. Also notice, the most important thing, you've got a symbol here that doesn't have a line underneath it. It strictly says greater than, which means I have to select a dotted line as my answer. So choice 3 is the correct choice here. Okay, which graph represents the solution to this? So something to notice, if you look at all these graphs, it looks like all these lines go through -3, and they all look like they have the same slope. So I don't need to worry about trying to solve everything. What I do need to do is check a point. So pick any point you want on the axis that isn't on the line. So let's pick this point up here. Let's pick the point 0, 3. And let's plug it into this equation. So 2 times 3 plus 6 is greater or equal to 4 times 0. That's what we're going to do. And if we do that, we get 6 plus 6 is greater or equal to 0. 12 is greater or equal to 0. Oops, sorry about that. And that's true. So since that's true, we want to shade where the point 0, 3 is. Well, so this can't be the choice. It's not shaded correctly. Neither can this one below. So it's got to be choice 3 or 4. Notice there's a symbol here of greater than or equal to, which means you have to have a solid line. So that's why we're going to pick choice 4. Okay, let's keep going. This next question shows which inequality. So if you look at this, first off, you can cross out choice 1 and 3 because it's a solid line. And then you have to decide if you're shading above or below. You kind of see in this case that we shaded below the line, which means you can just pick the less than. Or you can test a point. It's up to you. All right. Next question. Julie has 2 jobs. She earns $10 per hour walking her neighbor's dog and earns $13.50 per hour walking at Starbucks. Write an inequality to represent the number of hours X at dog walking, right, and Y working at the coffee shop. Julie will need to work for a minimum of $225. Julie worked 9 hours at Starbucks. using inequality to find the number of full hours she must walk her neighbor's lawn to reach the goal of 225. Okay, so let's start by doing this. Write an inequality to represent the number of hours X dog walking and the number of hours Y working in the coffee shop that Julie will need to earn a minimum of $225. Well, she'll get $10 per hour walking the dog, plus $13.50 per hour working at Starbucks. I'm going to call that S. Well, my S's and my 5s so look the same. So this is 13.5 times S. I guess we'll keep that. Actually, I'm going to use the X and Y we told me. I'm sorry. It's 10X plus 13.5Y. It says it here in the question. And I just was reading. And it has to be a minimum of 225. So that means the person has to make at least $225. Julie worked 9 hours at Starbucks. Use the inequality to find the number of hours she must work to reach her goal. So if she worked 9 hours at Starbucks, that means X is 9. You plug 9 here, plus 13.5Y is greater than or equal to 225. And I just need to solve this equation. So what am I going to do now? 10 times 9 is 90. This is 90 here. I'm going to subtract 90 from both sides. And I will get, as an equation, 13.5y is greater than or equal to, and then you have to do 225 minus 90, you would get 135. Divide by 13.5, divide by 13.5, and y is greater than or equal to 10. She'd have to work at least 10 hours. Okay, almost done here. Just a few more things to do, right? So graph the following system of inequalities. Let's take this first one. I'm going to move x over. So 2y is less than or equal to negative x plus 8. Divide by 2, divide by 2, divide by 2. Y is less than or equal to negative a half x plus 4. So we know how to graph that. We go up to 4. And then we go down 1 over 2. Down 1 over 2. Or up 1 back 2. Solid line, because it's got the equal to underneath. It's less than or equal to. So solid line here. Oops, it's sloppy. Sorry, let me just fix that. Oh, you know what I'm doing here. So we'll just leave it like that. X plus 2y is less than or equal to 8. For the other line, you don't have to do anything. It's already the correct form. That's going to start at 4. It's got a slope of 1. So I'm going to go up 1 over 1, just like that. Or down 1, back 1. Okay. And with that line, it's going to be dotted because it's strictly less than. Okay. So now what we need to do is figure out where to shade. So you can do a test point. I'm going to test the point 0, 0 because it's not on either line. So let's say I plug 0, 0 in here. I have 0 is less than or equal to 0 plus 4. 0 is less than 4. That's correct. So I have to shade below the blue line. This. If I plug 0, 0 in the first equation, then I would get 0 plus 2 times 0 is less than or equal to 8. 0 is less than or equal to 8. That's also true. I will shade below the green line. There you are. State a point that is in the solution of the blue. That's what this is, the blue area, but not in the solution of the green. So that could be any point. I'll highlight the whole area. Be any point over here that I'm shading in yellow. Because in that area, we're under the blue graph, but not under the green graph. So point might be, let's say I pick this point. So it's over 1, 2, 3, 4, 5, and then up 1, 2, 3, 4, 5. So 5, comma 5 would be the answer for that question. Okay, let's keep going. This one here, which point is in the solution for the system? So you need to pick a point that is in the double shaded area. So it's simply a matter of looking in here and which point is in there. This first point seems to do it. Because if I go to negative 4, 1, 2, 3, 4, and then down 1, negative 4, negative 1 is clearly in the solution. So that's that. Are there any other points there? Which point is a solution for the system? Oh. Yeah. Negative 2, 2 might be tempting, like this last one, but you go to negative 2, 2, you actually land on the dotted line. Which is not. Okay, just about. Next question. we have these two things. Which graph is the solution to these inequalities? So let's take a look at this one. You're going to have a y-intercept of -2 with a slope of 3 and a solid line. So this graph has a y-intercept of -2, a slope of 3, so it looks good. And then I'm noticing something. Without doing any work at all, if you look at the first equation, notice how it has y plus x is greater than 2. There's no line underneath here, so it should be dotted. So this can't be the answer because both graphs are dotted. This one might be. This one can't be. This one might be. So, you've got to have a dotted line. So 2 and 4 have the dotted line and one solid line. I need to check the shading. So, let's look at the equations. Let's see this one for example. Y plus x is greater than 2. So, that's a dotted line. Let's check a point. So, for example, let's pick a point like, you can pick any point you want. So let's say someone decided to pick the point 0, 3. You can check on the last problem. I do 0, 3, I get 3 plus 0 is greater than 2. 3 is greater than 2. That's true. So I should shade this way. So that's the answer it looks like, because in this case, they shaded below the dotted line, which wouldn't be true. So 4 is out. It's got to be choice 2. You can also graph that again. Okay. Solve the following system graphically. So we need to graph these things. So here I'm going to add 4. Y is greater than or equal to -1/3 x plus 4. And then here, if I try and graph that, let's do that. That's 4 up 1 over, oh, sorry, not up 1. It's -1/3. So down 1 over 3, down 1 over 3, and so forth. Or up 1 back 3, up 1 back 3, up 1 back 3. Solid line. Take that. Y minus 4 is greater than or equal to -1/3 x. Okay. This one, you know, before I do this one, I better test the point. Let's test the point up here. Let's test the point. What is that? 0, 6. Plug that in here. I would get 6 minus 4 is greater than or equal to -1/3 times 0. 2 is greater than or equal to 0. That's true. So I should shade above this line. For the second line, I'm going to move the 3 over, so I'll get -2y is greater than -3x plus 6. Divide by -2, divide by -2, divide by -2. Y is greater than positive 3 x minus 3. So I'll start here, and I'll go up 3 over 2, up 3 over 2, up 3 over 2. That's not correct, actually. There it is. Go down 3 back 2, down 3 back 2. Dotted line, because it just says greater than. You need to test. I'm going to test the point 0, 0. It's not on the line. Plug it in here, get 0 is greater than 3/2 times 0 minus 3. 0 is greater than -3, which is true. So I should shade above this line. And now you can see the double shaded area, this area up here, is considered the solution. Okay. State one point in the solution set. The point I showed before, you can see it right here, this point, 0, 6. There's lots of answers there. Okay. All right, so here's the throwback. Evaluate f of -4. Just follow the instructions. Put -4 in for x, and just do what it says. So -4 squared is -4 times -4. That's going to be 16. 3 times -4 is -12 minus 1. 16 plus -12 would be 4, minus 1 would be 3. That's what I'm going to do there. So following is in the solution set, so you just have to check and see which of these numbers work in this equation or inequality, or you can solve it. I think it's easy enough to solve. Let's just do that. -2 minus 2, -3x is greater than 9. Divide by -3, divide by -3. Now, notice we're dividing by a negative number. Very careful. We have to flip the sign. X is less than -3. The only number less than -3 on this list is -4. Very careful. Okay, here we go. Last problem. Is this a function, yes or no? It's a function if each input has only one output. That's the key. Each input has one output. So if you look at the input -4, it only has the output 16. If you look at the input -2, it only has the output of 4. 0 only has an output of 0. 2 only has an output of 4. Now, you'll notice that -2 also had an output of 4. That actually doesn't matter. You can have two inputs pointing at the same output. You just can't have one input pointing at two different outputs. And then finally down here, 4 also points at 16. That's okay. This thing, yes, is a function because every input only points to one output. Oh, there's actually a few more problems here. Write the equation of this line. So look for the slope. Ready? Slope y equals mx plus b. B is the y-intercept. You can see that right here. It's got to be -1. Y equals mx minus 1. To get the slope, pick 2 points. And I'll pick these 2 points. Ready? So it's going to be 2 minus -1 on the top. And then on the bottom, you're going to have 1 minus 0. You would get 3 on top, 1 on the bottom, so your slope is 3. The final equation, y equals 3x minus 1. It's the next problem. Okay. Finally, we're going to solve this for x. To do that, you're going to use the distributive property. So we multiply here, you would get 1 minus 3x. Here, you're multiplying by -4, -4x. And then -4 times 3/2 is -6. Over here, you have to distribute a negative, so it becomes -x plus 3 plus 4. Wow, that's a lot of stuff. Okay, let's combine some like terms. So the 1 and the -6 can become a -5, and then the -3 and -4 can become a -7x. That's going to equal over here -x plus 7. We're going to add 5 and add 5. Get, here we go, -7x equals -x plus 12, right? Add x, -6x equals 12. Divide by -6, divide by -6, and after all that, x equals -2. That was a lot of math. Thanks for watching. Good luck, and we'll see you tomorrow.